So we do have example one here. This table gives the percent of US households with internet access in various years since 2005. Find both a linear and a quadratic function that models this data. Okay, we're going to start with that and then we'll answer these other questions later. But what I would encourage everyone to do is right out of my presentation here, highlight the information, copy it, and paste it over into a Google sheet. And so it doesn't have to look pretty or perfect or anything, just get it pasted in there. And I'm pasting it from a PDF. I have verified that this will work if you paste it right from the presentation that I have shared with you as well. So again, it would just look like that, copy it, and it actually comes across a little bit better in my opinion. This is from the presentation that you receive in the course plan, and this is from my PDF over here. Again, both of them will produce the same result. So what we need to do in order to get an equation for a line of best fit that we can use to tell what's happening and predict what's going to happen in the future, we need to highlight all of these cells. We need to say insert and a chart. So this is automatically going to put a chart on here that has a line like this, everyone. It's going to call it a line chart. You'll see that over here, this menu will pop up. What we want to do is change this to be a scatter plot or a scatter chart. So we've got points there like that. Now each of those points represents one of these pieces of data in this table. Okay? And one of the things that we're going to need to do is you'll notice our x-axis has gigantic numbers like 2006, 2008, 2010, 2012, 2014. That's going to mess our equation up and we're going to get some really nasty numbers because it's going to think that those are the x values that we're using. So one of the things that we need to do initially to fix this is we need to highlight these cells right here and we need to insert cells to the left. So I'm going to shift that right so I get another column here. And we are talking about the years since 2005. So I need to add a column that is since 2005. And 2005 is 0 years from 2005, 2007 is 2 years from 2005, 2009 is 4 years from 2005, 6 years, 8 years, and 10 years. So this graph, actually instead of having 2006, 2008, 2010, 2012, we don't want that, so we're going to get rid of that graph. And we want this data only, not these years over here that we were given. So again, we're going to go up to Insert, Chart, and it's already been selected to be a scatter plot. Now you'll see that our x values are much more friendly. So that's going to make an equation that actually means something and makes sense. Because if we left the 2000 and something in there, again, our equation would just come out totally stupid looking, and we don't want that. So what we need to do now, everyone, we do have the data listed here. We're going to go over to Customize in this tab. We're going to go to Series. And we are going to tell this thing that we want to add a trend line. So a trend line, another word for that is we also call that a line of best fit. And so you'll see when I check trend line, I get another menu underneath there. By default, it's going to be linear. And so we were asked to find a linear and a quadratic function that models this data. So here is the linear one, but I don't see a function or an equation anywhere. What we need to do is come down right here where it says label and put use equation. And you'll see that the equation pops up right here. So everyone, this is the linear equation that represents that data. And it's not really the best equation, I guess. It kind of fits it, sort of, but I think we can probably do better. So what we're going to do, everyone, is if I click on this chart, I have to double click on it to get this menu to pop back up. I go back to series again. I've got to my linear equation. And we want now, instead this time, below our trend line here, we want not linear, we want polynomial to the degree of 2, which is a quadratic. So now I've got a new equation, and it looks like this line actually fits the model a little bit better to me. There's going to be some stuff in this work, everyone, that is subjective. And some people might say, no, Schlegel, you're crazy. The linear model fit it way better. Whatever you think. This is just, we're using this purely to speculate and try to predict what's going to happen in the future and that sort of thing. So we were asked to come up with both a linear and a quadratic. We've done that, and I'll go ahead and put y equals in front of these so that they look more like the equations we're used to seeing. And so again, we've got these equations now. Now using the model that fits the data the best, predict the percent of US households that will have internet access in the year 2020. Now, so remembering that we made our x values these numbers instead of the year, we need to remember that 2020 would have a value on our grid of 15, because that would be 15 years after 2005. So we're going to take our equations. I'm going to do the linear one first. And remember, this is 15 years after. So we're going to put 15 in where we had x. This model, the linear, predicts that in 2020, 93.55% of the US population will have internet. So I'm just going to type that in here, 93.55%. And then we'll do the same thing for our quadratic equation. And we'll see here, we've got to put a times 15 right there. We've got to put a times 15 right here. And this model predicts 86.61. So we could choose which model we think fits best. I personally think the quadratic fits best. Seems to match what's going on with the data a little bit better. We can see that it sort of flattens out over this way, and these last two dots here are kind of flattening out. This is saying that the percent of US households, and again, you could choose this one if you want to. These are subjective to a degree. I'm going to say this one, everyone, and I'm going to say for part B. So these two equations right here are part A, right? And then for part B, I would say I use quadratic. It predicts 86.61% of US households had internet access in 2020. Okay. And in part C, in what year does your model predict that the percent of US households that with internet will reach 100%? We're going to do both of these again, just for me to show you some stuff. And so here's my linear function. For this, I would put 100 over here for y, because that's 100%. So this is saying about 19 years after 2005. So the linear model, 19 years after 2005 would be the year 2024. And let's do the quadratic. And I think we're going to have something weird happen here with the quadratic, everyone. We do. So you see how we get our complex solutions? These have imaginary numbers in them. This means it's never going to happen. So the quadratic, what's happening in this quadratic, everyone, if we were to carry this out, the quadratic would come over here, and it flattens out to the place where it would actually start to drop again, because if you remember, a quadratic function is either a happy face or a sad face. This quadratic is a sad face, and so it would eventually top out here somewhere and slowly start to come back down again. It never reaches 100%. So the linear model says 2024, the quadratic says it's never going to happen. Which of these is correct? I'm not sure. Let's Google it. Today, over 90% of Americans have access to the internet. So it looks like the linear model was actually more correct, over 90%. Pretty crazy. And if that linear model is correct in the prediction going forward, the linear model would predict that in 2024, everyone in the United States would have internet access at their home. I think these are sort of fun, everyone. If you need to watch the video a couple times to get the hang of how to do it, that's totally okay. The important thing to remember, though, is that many times we're going to have to add a column to the data to produce X values that are nicer than the ones that we are given. With that, on to the next example.